Lesson 6-2, solving systems by substitution. Sometimes it's hard to get the exact solution to a system by graphing, so we have some other algebraic methods instead. And for this, you're going to need both Notes page 81 and definitely a sheet of binder paper. There's not room for all the examples we're going to do, so grab that binder paper. A substitution, the big idea here is that we're going to take a system of equations that has two equations and two unknowns in it, and we're going to reduce it to one equation that only has one variable, and you know how to solve those. It'll be something like x plus 6 equals 12, or 2x plus 5 equals 9, something like that, and then you can solve for x. You can plug that back in, you can find out what y is. So the first thing you're going to do is there on page 81, you're going to write down these 5 steps. Now there's a nice box there for you to do that, so it should be very easy for you to get it filled in. Okay, and I'm going to let you pause the video rather than talking through it, because I'll be talking through the steps as we do the sample problem. So go ahead and pause it, write all that stuff down. Now that you're back, we're changing to the next slide. And this is the example that is at the bottom of the page. Now you'll notice at the bottom of the page it looks like 4 examples, and that's because what I'm trying to get you to see, and what the textbook is trying to get you to see, is that there's a lot of different ways to do this problem. Okay? One of those first steps in the list of steps is that you have to get one equation solved for one variable. And if you look at that first box in the top left, it says solve x plus y equals 8 for x. So we're going to take this equation and we're going to solve it for x. That means I need to subtract y from both sides. So now I have my equation solved for x. X equals 8 minus y. I could rearrange it. I don't really have to, though. And then I take that and I put it in place of the x in my second equation. Okay, that's why it's called substitution, because I'm going to substitute one expression for another. And when I do that, then I get 8 minus y, that's what x was, minus y equals 2. And if you zip zap, right now you can see that we have 8 plus negative 2y equals 2. Subtract 8 from each side, and you get negative 2y equals negative 6, so y equals 3. Then we take that, we plug it back into either equation. We can even put it back into the one we already rearranged to find out what x is. So x is 8 minus y, or 8 minus 3, so x equals 5. And we get 5, comma 3. Okay. Now the box on the top right says solve x plus y equals 8 for y. So now we're going to do it again. I'm going to change color pens. I'm going to draw a nice line here, and I'm going to show you how you get the same answer even though you're doing it differently. Okay. So this time we're going to solve for y. So if we had x plus y equals 8, then to get y by itself we would need to subtract x from each side. So there's my equation solved for y. Then I'm going to plug that into my second equation. I'm going to replace, here's my second equation, I'm going to replace y with 8 minus x. Now this is a little trickier because we got that minus there, so let's make this plus negative. Maybe that'll help us. So we have x plus negative, let's even make it negative 1, 8 minus x equals 2. Let's zip zap that also. We get x plus negative 8 plus negative 1 times negative x is x equals 2. 2x minus 8 equals 2. Add 8 to both sides. 2x is equal 10. So 1x equals 5. That better be what we got before. It is, right? And we should get the same answer every time. And we know that y equals 8 minus x, which is 5. So y equals 3. Same final answer. I want you to pause the video and try the other two, solving for x and then for y in the second equation. You should keep getting the same answers. This is 4 different ways to do one problem. You'd only really need to do it one way. They're showing you how you can do it any of 4 ways. So go ahead and pause it and do that. Now that you're back, we're going to try a couple more. So on your binder paper, well, maybe, there we go. We're going to try a couple more. So we're going to solve this system. Write it down, y equals 3x and y equals x minus 2. Now both of these are already solved for y, so that makes your life easy, right? You get one equation solved for one variable, done. So now we can just go ahead and decide which way we want to plug things in. Doesn't really make any difference. So I'm going to replace y with 3x. That's what this is saying. They're equivalent. So plug in 3x for y. We get 3x equals x minus 2. Get all the variables onto one side. This is a good chance to practice all your basic algebra skills. And we get 2x equals negative 2. So x equals negative 1. And we plug that back in. Y equals 3 times x. And we get negative 3. And so our answer is negative 1 comma negative 3. And we should double check it. We know it works in the first one because that's what we just did. It's a good idea to check it in the second one. And we get negative 3 equals negative 1 minus 2. And that is true. It's always worth checking your answer. I know many of you don't think so, but believe me, yeah, you could avoid a lot of mistakes on tests if you took 30 seconds and checked your answers. Let's try another one. Okay. Remember, we're looking for the one place where our two lines intersect, that ordered pair. That's what we're looking for every time. Write down this example, y equals x plus 1, and 4x plus y equals 6. Once again, we have a really nice setup here because one equation is already solved for y. So don't make life hard. Go ahead and take what you have y equivalent to and substitute it in for the y in the second equation. So 4x plus y is now known as x plus 1 equals 6. 5x plus 1 equals 6. Subtract 1 from each side, and you get 5x is equal 5. And divide by 5, and you get x equals 1. Ooh, I almost wrote 5 there. Plug it back in to either equation, but I'm going to pick the one that's already solved for y. And I get y equals 1 plus 1, which is 2. So my solution should be 1 comma 2. That's where they're going to cross. If I graphed it, like I did in class, right, for lesson 6-1, I should find that they would cross at 1 comma 2. Let's double check that it works in the second equation. 4 times 1 is 4, plus 2 makes 6. That is true, so my answer is correct. Now sometimes substitution problems are a little bit more complicated when you have a coefficient. Okay, don't forget you have to put it into the second equation. All right, hold on, we're going to skip that one. When your second equation has a coefficient, whatever you're substituting in, you're going to have to make sure that you use the distributive property. So I don't think you really need to write anything down from this slide. You just need to pay attention to what you're doing when you're doing your algebra. So let's try an example that looks like this. A little harder. Y plus 6x equals 11. 3x plus 2y equals negative 5. First thing I have to do is I have to choose which equation I want to solve for which variable. The simplest one is the best. So what I see is that I already see y almost all by itself. It doesn't have a coefficient in front of it. So that's what I'm going to solve for. I want to solve for y. And if I want to solve for y, I'm going to take 6 x's away from each side. So now my new equation here is y equals 11 minus 6x, or negative 6x plus 11, either way. Now I'm going to plug that in for y. Right, so I'm taking 11 minus 6x, and I'm putting it in place of y. That looks like 3x plus 2, and then y is 11 minus 6x equals negative 5. Distribute. 3x plus 22 minus 12x equals negative 5. Combine like terms. 3x and negative 12x makes negative 9x's plus 22 equals negative 5. Subtract 22 from each side, and you're going to get negative 9x equals negative 27. And then when you divide, you should get x equals 3. It is a lot of algebra. It's good practice. And then we're going to plug it back into our original equation. Well, actually, I'm going to plug it back into the one I solved for y, because that'll be a little bit easier. So y equals 11 minus 6x, and x is 3. So we have 11 minus 18, which means that y equals negative 7. So my answer should be 3 comma negative 7. And let's double check that in my second equation. That's not the one I used to find my values when I found the y value anyway. So let's just make sure it works. 3 times 3 is 9. Plus 2 times negative 7 is negative 14. And that does equal negative 5. So that seems like a pretty good chance that my answer is correct. Put a nice box around it. One more, and that'll be it for today. Or tonight, as the case may be. We'll do some word problems and some more in class. So this will be our last one in your notes. This should be, I think, 4 examples on your binder paper. Okay, we're going to take a look again at our equations, see which one we want to solve for which variable. Today's looking like a day where we want to solve often for y. So just go with it. It's not that we're always solving for y. We're always solving for what seems the simplest. And what seems simplest is getting y by itself. So I'm going to add 2 x's here and add 2 x's here. So my equation is y equals 2x plus 8, or 8 plus 2x. And then I'm going to replace y with 2x plus 8. So I get 3x plus 2 times 2x plus 8 equals 9. Distribute. 3x plus 4x's plus 16 equals 9. 7x's plus 16 equals 9. Subtract 16 from each side, and we get 7x's equal negative 7. So x equals negative 1. Don't stop there, though. Put it back into the equation we solved for y. Y equals 2 times negative 1 plus 8. And negative 2 plus 8 is positive 6. So it looks like our answer should be the ordered pair negative 1 comma 6. That's where they're going to intersect. Double check it in that second equation. Negative 3 plus 12 equals 9. That is true. Right, and it should work in the first one too. 2 plus 6 equals 8. So we're good to go. Put a box around it and you are done. Word problems and a few more examples tomorrow when you get to class. Bye-bye.